Imagine the car you drove today. Think about an individual component that makes up that car. Ask yourself, what is this made out of and why? There's tons of different materials that make up cars that you probably would think would be like metals, plastics, and other materials. Engineers do a lot of different testings in industry today that help determine what kind of materials they would need to put in a car. Some things they look into would be the material properties. Some common tests that are used to determine what kind of material would be used and get some material properties would be hardness testing. A common form of hardness testing would be Rockwell HRB and Rockwell HRC hardness testing. As a teacher's assistant for the metals lab at Rochester Institute of Technology, I'm able to witness a day-by-day use of the hardness tester in the metals lab, as many students use it to determine some mechanical properties for metals in this lab, such as steel and aluminum. Some things that you wouldn't think about would be all of the different materials and how hard or soft they would be, which is an interest when you're thinking about how to choose a material. Some things I'll be discussing today is what is hardness testing, what are the different Rockwell hardness tests that we can do, and a little bit about the test. So let's talk about what Rockwell hardness is. So Rockwell hardness is the amount of force put down on the material to determine how hard it is. So we use a lot of different indenters to do that. And some common indenters that we do today that we know would be our HRB and HRC. So for example, our HRB indenter is a round 1/16 inch ball indenter that is used for some soft materials like copper and aluminum. Our HRC indenter is a diamond-shaped indenter used for harder materials such as steel or cast iron. Selecting your indenter is one of the first things you can do to start your hardness test. Some things that would help you choose what indenter to be using is depending on how hard or soft your material is, or just what material it is if you know. If you don't know what your material is, just start out with HRC, so that way there's no chance you can ruin or damage the indenter. So some common materials that I have today that I'll show you to run through a basic procedure would be this cast iron steel, which is a flat sample, and this round stock piece of aluminum. I'll be showing you how to hardness test this round stock of aluminum. But for example, we have different platforms that we use for the hardness test. So for a flat piece like this, we would be using this flat block right over here that is inserted into this piece right here in the hardness test that allows the piece to rest flat underneath the indenter. Another piece that we'd use for a round stock piece like this aluminum piece would be this V block right here, which you can see is in the shape of a V. That is also inserted in the same little hole right there. And what happens is it allows us to lay our surface in the V block, and it creates a flat surface for the indenter to come down and take an accurate reading. So we have decided that we are going to use an aluminum piece. So I'm going to use the HRB indenter, which is the ball shaped right here, and I'm going to insert it right here into the set screw right here. And I'm going to screw it tight in here. Okay, so everything is set to go and ready for the test. So some other things we have to consider when we're using a round piece is the correction factor. So one way we can get our correction factor is measuring the outer diameter with our dial calipers. So the dial calipers look like this. You want to also make sure that your dial caliper is zeroed properly prior to taking the diameter reading. So I will take the outer reading, and my reading shows that it's 0.50 inches. So on my screen right here, I have my main menu. So under my main menu, I'm going to be wanting to work on adjusting my correction factor. So I'm going to go under correct. And under correct, I'm going to say, make sure my corrections is on, which it is. And I'm going to adjust my diameter. I'm going to type in 0.50 and hit OK. So my diameter is updated, and I know my correction factor is on because I can see the semicircle with the arrow pointing down, indicating that my correction factor is on. So now I can hit OK. I can insert my part into the V block, and I'm ready for testing. So one other thing prior to testing is I can adjust the length, the initial height of my indenter by using these arrow keys right here. So if I click the up one, it moves the indenter up. If I hit the down key, it also moves it down. So I'm going to try to get the initial height a little bit closer so it doesn't take so long to run the test. So I'm starting at about 1/2 inch from the top of the surface. So the next step in order to start the test is to use this green button right here, which will initiate the test. So I will press this once, the indenture will slowly move down onto our aluminum sample that we have here, and it is going to apply a certain force with the indenture into the part, and what it's going to do is it's going to record how much force is required to make that indent, which is going to give us a hardness reading up on the screen. So the hardness for this round sample is 81.07 HRB, which is what we record in the sample. So some things we discussed today was what is hardness testing, what are the different types of Rockwell hardness testing that we do, as well as talking about some of the indenters, and we also discussed how the test is run. So as we asked you earlier, what do you think engineers do to decide what material to use for a car? And now we can answer, well, they look at their mechanical properties. And now you know what kind of mechanical properties they can look at, such as hardness testing, which is what we did today.